Let's try few questions from resistors in series and parallel. Try this first question. The diagram shows two resistors connected in a circuit. What could be the combined resistance of this arrangement of resistors? Your time starts now. The correct answer is D, because here you can see these two resistors are connected in series. So the formula for two resistors connected in series is R1 plus R2. So we can consider R1 as 6.0 ohm plus R2 as 12 ohm. So by adding this both resistance value, we get 18 ohm as the total resistance for these two resistors. So the correct answer is D. Try this second question. The diagram shows two resistors connected in a circuit. What could be the combined resistance of this arrangement of resistors? Your time starts now. The correct answer is A. Let's see the calculation part. Here these two resistors are connected in parallel. So to find the total resistance, the formula is 1 by R equal 1 over R1 plus 1 divided by R2. Let's substitute the R1 and R2 values. So 1 over 6.0 ohm plus 1 over 12 ohm. So we have to find the LCM of 6 and 12. So 6 and 12, let's start with the 2. 3 times 2 is 6 and 6 times 2 is 12. Then again we do with the 2. 3 as it is. 3 times 2 is 6. So again we do with 3. So 1 times 3, 1 times 3. So 3 times 2, 6. 6 times 2, 12. So the common multiple for 6 and 12 is 12. So when we multiply 2 with this 6, we get 12. So with the same number we have to multiply here. So 2 plus here 12 times 1 equal 12. So with the same number we have to multiply. So 1 equal 3 divided by 12. So remember, now we got 1 over R equal 3 divided by 12. Mostly students do up to here correctly, and with the calculator they find the value 3 divided by 12 and they write the final answer. But remember, this is not R, this is 1 over R. R over 1 equal 12 over 3 equal 4.0 ohm. So this is the final answer. Let's do with another formula. As I have mentioned earlier, if only two resistors in parallel means we could use another formula, that is R1 R2, that is R1 times R2 divided by R1 plus R2. So let's substitute 6 times 12 divided by 6 plus 12 equal 72 divided by 18, that is 4. So total R for two resistors connected in parallel is 4 ohm. Please do remember this formula can be used only for two resistors connected in parallel. More than 2-3 resistors, you have to use this formula. I hope you got it. Try this third question. Two resistors are connected in parallel. Which value could be the resistance of the combination? Your time starts now. The correct answer is A. Let's see the calculation part. Here these two resistors are connected in parallel. So to find the total resistance, we have to use the formula 1 by R equal 1 by R1 plus 1 by R2. So let's substitute the values. 1 by R equal 1 over 20 ohm plus 1 over 30 ohm. So we have to find LCM of this 20 and 30. Let's find that 20 and 30. Let's start with the 2. 10 times 2 is 20. 15 times 2 is 30. Again we can do with 2. 5 times 2 is 10 and 15 as it is. Then we do with 3. 5 as it is. 5 times 3, 15. Then again with 5, 1 and 1. So 5 times 3 is 15. 15 times 2, 30. 30 times 2 is 60. So the common multiple is 60. So with the 20, if we multiply with 3, we get 60. With the same number, we have to multiply here. So 3 plus with the 30, if we multiply with the 2, we get 60. So with the same number here, 2. So 2 equal 5 divided by 60. Again, this is not the final answer. Here it is 1 by R. We want R by 1 or R equal 60 divided by 5 equal 12. That is 12 ohm. Let's do with another formula which can be used only for two resistors in parallel. R equal R1 times R2 divided by R1 plus R2. This is R1 equal 20 times 30 divided by 20 plus 30 equal 600 divided by 50 equal 12. So that is 12 ohm. So A is the answer. Try this fourth question. The diagram shows a 40 ohm resistor and a 60 ohm resistor connected in parallel. What is the total resistance between points P and Q? Your time starts now. the correct answer is A. Let's see. Here 60 ohm resistor and 40 ohm resistors are connected in parallel. Please do remember that when these two resistors are connected in parallel, the total resistance will be always less than the lowest resistance. It means here 60 ohm and 40 ohm, among these two, 40 is the lowest resistor. So the total resistance will be less than 40 ohm. So let's try by using a simple formula which you are familiar. R equal R1 R2 divided by R1 plus R2. So let's put bracket. So let's substitute 60 times 40 divided by 60 plus 40 equal, when you times 60 with 40 you get 2400 divided by 60 plus 40 is 100. So the answer is 24 ohm, which is less than 40. So you can use another formula also, that is 1 by R equal 1 by R1 plus 1 by R2. You will get this 24 ohm. So it is less than 40. That means lower than the lowest resistance. I hope you got it. Try this fifth question. A student connects various resistors in parallel pairs. Underneath each diagram is a statement about the total resistance of each pair of resistors. Which statement is correct? Your time starts now. The correct answer is C. Let's see the calculation part. Any method you could use to determine the correct answer by applying our formula 1 by R equal 1 by R1 plus 1 by R2, or R1 R2 divided by R1 plus R2. But as we discussed in the previous question, easily you can find the correct answer from this question. As I have mentioned before, here two resistors are connected in parallel. Let's see each one. In option A, the total resistance is 4 ohm. When will we get this total resistance? 4 ohm means when we add this 2 ohm plus this 2 ohm, that is two resistors in series. So option A is not the correct answer. Here the total resistance is between 1 ohm and 5 ohm. Remember that between option is given, so we will not consider this one. And D, the total resistance is more than 20 ohm, and C, the total resistance is less than 5 ohm. As we discussed in the previous question, among this 10 ohm and 5 ohm, the lowest resistance is 5 ohm. So when these two are connected in parallel means the total resistance will be less than this lowest resistance. So the total resistance is less than 5 ohm. If you want, you can apply the formula and check the answer. Try this last question. Identical resistors are connected together to form arrangements X, Y and Z. What is the correct order of the resistances of the arrangements from the largest to the smallest? Your time starts now. The correct answer is D. Here in the question they have mentioned largest to the smallest. So when the resistors are connected in series, then the total resistance will be very high. So first largest will be Z, that is these three resistors. Then second one is again here these two resistors are connected in series, so total resistance will be higher. So next it is Y, and here you can see two resistors are connected in parallel, means as you all know total resistance will be less than these two connected in series. So last order is X. Arrangement X will have the smallest resistance, so D is the right answer.